Hello friends, today we'll study about the Frank Hertz experiment. The aim of the experiment is to determine the first excitation potential of argon gas by Frank Hertz experiment. Let's have a brief introduction of it. So while solving the problem of blackbody radiation in 1900, Max Planck put forward the idea of quantization. He proposed that the exchange of energy between radiation and matter is discrete rather than continuous. Then in 1905, Einstein put forward photoelectric effect, assuming quantization of light. Inspired by the success of Planck's hypothesis and Einstein theory, Bohr proposed the quantization theory to explain hydrogen atom spectrum. According to Bohr, electron in an atom revolves around the nucleus in circular orbits under the electrostatic attraction. These orbits are known as stationary states. Electrons are allowed to move in certain set of orbits with discrete energy values where their angular momentum is integral multiple of h upon 2 pi. Bohr successfully explained the hydrogen spectrum and established the belief that transfer of energy of electrons in an atom is in discrete amount rather than continuous. However, it required endorsement from the experiments. So in 1914, Frank and Hertz explored the mechanism of energy transferred through inelastic collisions in mercury vapor. They discovered that electrons having energy greater than certain critical value can excite electromagnetic radiation, whereas electrons having energy less than that value bounce off elastically and fail to excite any electromagnetic radiation. This experiment provided crucial evidence in favor of Bohr's theory and was a key in the development of quantum theory. Frank and Hertz shared the Nobel Prize in 1925 for this discovery. Main part of a Frank Hertz experiment is a tetrode tube. It consists of a filament which heats up the cathode. This K is an indirectly heated cathode, and it emits out electrons by thermionic emission. So when electrons are emitted out, they form a cloud near the cathode. So to avoid this, we put a grid G1 which is kept at a positive potential with respect to the cathode. Accelerating potential is applied by introducing another grid G2 which is kept positive relative to cathode and anode plates. So G2 acts as a filter for higher energy electrons to pass through it. Electrons with sufficient kinetic energy can reach anode and contribute to the plate current, and which can be read by the nanometer. Plates K, G1, G2 and A are in parallel plate configuration and produce uniform electric field. So this tube is filled with argon gas. Frank Hertz originally used the mercury vapor. Usually a monoatomic gas, for example argon, neon, mercury, can be filled in chamber in order to prevent complications involving molecular transition. So while electrons are moving from cathode to anode, they collide with argon atom inside the tube. This collision may be elastic or inelastic in nature depending upon the energy of the electrons. If energy of the electron is less than the excitation potential of the argon, which is around 11.83 electron volt, it collides with the argon gas atoms elastically, and energy loss in the electron will be negligible as mass of electron is very less than mass of argon atom. The electrons would pass through the anode and collector current increases with increase in accelerating voltage. But if the on increasing the voltage, energy of the electron is sufficient enough, more than 11.83 electron volt, it is used up by the argon atom and is used to excite its own electron to the higher excited state, and thereby the incident electron loses almost its energy and is not able to reach the plate. Therefore the plate current falls. Again, on increasing the accelerating voltage, if the energy of the electron again becomes integral multiple of this excitation potential, Again it is used up by the argon atom to excite more electrons to the excited state, and the current again falls, and thereby increasing this maxima and minima are obtained by the in the plate current. That can be seen here, so that we have peaks and dips in the plate current with increase in accelerating voltage. So now let us have a look on our experimental setup. So this is a setup for Frank Hertz experiment. The tetrode tube is kept inside this box. Then we have this as a current display unit. So, and this is the voltage display. It tells all the voltages with respect to all the grids. So this is our current multiplier. So we can put it at 10 to the minus 9 or 10 to the minus 8 or 10 to the minus 7 amperes according to our need. This is filament voltage. So we can apply a voltage. So whenever filament voltage is changed, please allow 2-3 minutes for its stabilization. So these are the knobs for changing the voltage with respect to G1K or G2A and then G2K, and accordingly we have to flick this switch for G1K, G2A and G2K. So we have another switch here which is manual and auto. So generally we perform the experiment with manual, but this with auto we can use the CRO. So this is the scanning voltage and these are the 3 knobs for connecting it to the CRO. So then we can get the waveform on the CRO, but generally we do it with the manual. Now let us start the experiment. So to start with the experiment, first thing is that whenever we want to switch on these apparatus, we must ensure that all the knobs are at their minimum position. So we should check it and then only we can switch on the device. So now first set the filament voltage so that by the time we start our experiment it gets stabilized. So a 2.6 voltage is given to that. Then we set the G1K voltage which is kept as 1.5 volts, and then we will flick it to the G2A and this will be kept as 7.5 volts. These are the suggestive values. Then we keep it to the VG2K voltage and then increase it by very small amounts and then keep on noting down the current. We can set the multiplier to 10 to the minus 8 and then increase the voltage. We will see that as we go on increasing the voltage, first it increases with increasing the accelerating voltage and then at some stage it decreases. For example, here we can see that it is decreasing and then it starts again increasing. So in this way we will keep on changing the VG2K values and then noting down the current. We can go up to the 60 volts, but we have to keep an eye that the current should not increase suddenly. If it happens so, we must stop the experiment at that moment because it may damage our tetrode valve. I have tried to show the values, the current, how it is increasing and decreasing in between between some intervals, because to show all the data here is not possible. So what we do is we note down this data in a table and then we have to plot the graph. So now I want to share one precaution with you, that is whenever we want to switch off the device, we must ensure that all the knobs are at their minimum position. Check it and then only you can switch off the device. Now let us proceed for the next step. So whatever readings we have taken, we must write down in the observation table. So first we will note down the filament voltage, then VG1K and VG2A voltage, and then we will note down the variation of plate current with respect to the accelerating potential. So, and plot the graph. So the graph, on x-axis we plot potential and y-axis plate current. So the graph comes out to be this. We can see a number of maximas and minimas here. We can also observe that the difference between two consecutive maximas is same, and similarly the between two consecutive minima is same. So to minimize the error, we take the difference between nth minima and first minima and then divide it by the number of dips over there. Similarly, we can take the difference between the nth maxima and first maxima and then divide it by the number of maximas in that interval. So the formula used is that if Vn is the potential corresponding to nth peak and V1 is the potential due to first peak, so the excitation potential is Vn minus V1 upon n minus 1. As seen from the curve between the current and the accelerating voltage, the electrons can excite the argon atom only if they are accelerated by a specific value of the voltage or its integer multiples. So this verifies the discrete atomic energy levels of the argon atom. Value of spacing between peaks is around 11 electron volt compared to the first excited state of the argon atom. Now let us discuss some precautions. So during the experiment, if the current changes suddenly, we must at once decrease the voltage to avoid the damage to the tube. Then whenever the filament voltage is changed, we should allow at least 2-3 minutes for its stabilization. And whenever we switch on or off the device, we must ensure that all the knobs are at their minimum position. So that's all about this experiment. Thank you and have a nice day.